So first of all, what we're going to talk about today is why, what, and who is Altwork. We're going to talk about the path to create the Altwork Station, and then that iterative development in hardware. So the first of all is the why. We believe that there's a better future being created on a computer with a person right now today. Everybody talks about AI right now. I really believe in what we should call augmented intelligence, the human brain working in its creative way, augmented by a digital calculation machine, has created incredible things. We think there's more incredible things coming to be. And what we want to do is we are working the body side of that problem to create a tool that helps people be more productive, more creative, and more comfortable. There are three things that are correlated: productivity, creativity, and comfort. It's very interesting. I know we all want to say just suck it up and push through your discomfort. The reality is you can't be creative. Human mind's physiologically impossible to be in a state of distress and a state of creativity at the same time. And productivity is correlated with comfort. So who did we create this for? The millions of professionals whose job is focused on the screen. Everyone in here understands that. So what we created was the Altwork Station. The open floor plan does a lot of good things. Where it's not the best is focused work. So we wanted to excel at focused work. We wanted to encourage movement. Right? We made a big bet 5 years ago when sitting was the new smoking, and now standing's the new smoking too. So what's cool, we made a big bet that it was going to be movement, and that's where we ended up with. So we wanted to make it really easy to move between positions so that throughout the day you can change positions. Obviously it needed to be much more comfortable, right? Not just a little bit, but much more comfortable. Compact in the office because you got to fit tight, and then we did this thing, everything on wheels. So we could literally unplug this from the wall here, roll it to the other side, plug it in, and rock and roll. You're ready to go. We see this as 4 productivity positions, right? Traditional sitting, of course, traditional standing, collaboration, either for 2 people, like you guys do a lot, but with the screen up and go into this kind of position here, we routinely do meetings of half dozen to a dozen people without grabbing a conference room. And then, of course, what we believe we do better than anyone else is the focus mode, the ability to really get deep on a project, be very comfortable and very focused on that work. Lots of press for those people that may have seen us. Our customer feedback is awesome. This was developed in secret for 5 years, released to the world about 1.5 years ago, unveiled, and we started shipping the first products about 6 months ago. So people really like their Altwork Station. I emphasize that while I am an inventor and I'm the CEO, this is a team effort, right? To try to make something like this, not only do we have a huge amount of engineering, but logistics support, ID, marketing, everything to make this work. So now we're going to start getting into a little bit about what we put together and what I want to talk to you about specifically today. So the first thing is this starts out with human-centric computing versus computer-centric computing, right? So what we want to do is we want to put the human at the center of this experience versus the computer at the center of the experience and letting the person move to the computer, right? That's what we all do right now. That's what we've been doing since the 1800s when we started putting typewriters and calculators on desks and bending to those. I need someone as a volunteer who is done with lunch. For just a minute, I want to show how that works live. Anyone? Thank you. So first of all, stand-up desk, right? If you adjust here and here, just find the height that works for you. And then set in the stand-up memory position, and it sets like your car seat. It's that simple. Also, if you
raise the monitor.
Only there was a button to do that. and tilt. We wanted to make the memory positions easy to reset. So like some of our team members will change shoe height throughout the day, right? So we want to make it easy to change up and down. So that's set up for you now. So, and we'll push the push and hold the 2 button. Everything's push and hold. And have a seat. Oh, let me show you how the desk works. So the desk tilts, all right? One of the tricks was to get this stuff to do this. So we do this with magnets. From a mechanical engineering point of view, we needed a sheet of steel underneath here for high modulus of elasticity, right? So that we can get good stiffness on this arm. There's a release under here, so this will move in and out. The desk weighs 15 pounds. It'll come into your lap because it's moving with your body. If it's ever too heavy, you lift until you hear that click, and then you can just push down wherever you want. Okay? And then push and hold 2 when you're ready.
And then push and hold 2?
Yep. They're all user settable, so it's just whatever works. I'll talk a little bit more about why that is when I get to some of the pictures. It gets better.
Wait, hold on, I missed something.
There you go. And then push down. Common problem that we have in this. With that side, yeah. Okay, pretty comfortable? Push and hold 2, it's going to get way better. And adjust the headrest up for you a little bit. How's that? All right. So, what we mean by, that's perfect. And if you let me drive, would you put one finger here and one hand on the keyboard? So this is what we mean by human-centric. So I'm going to go forward. Monitor keeps the same eye distance and same angle. Desk moves with his hands the entire time. So the computer's moving around him versus the other way. If you push and hold 4, you'll go all the way back. And so wherever you want to be, and if you go back to 2 whenever you're ready, you can do whatever you want. It's all about where you want to put the body, and the computer moves to you instead of what we have in the traditional setup. Let your elbows rest on the wings of the backrest, and just move these things down for you. I never worked this reclined. Our CTO was rear-ended in 2003 on the freeway, and his back will never be quite the same. He only likes to work this reclined. In our early research, we found that every person was different in how they wanted to work with their computer. So this is what we mean by human-centric computing, not lay-down computing. Lay down, sit, easy to move. You don't have to disengage your conscious mind in order to adjust for your body. And you can go right from there all the way to standing, and it just works. Hang out as long as you want. So when we fly, we have a thing called business class. That is a little micro-environment that's really cool and awesome, but we're still densely packed. If we get a car that we justify for productivity in the back seat, we have things that move around us and support the body. And then this is the reality of the modern office. So in the 1800s, we start getting calculators and typewriters that are probably more valuable than the person operating them at the time. And we just bend to them. And you can see here is the exact same thing we see here, 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 right? Nothing's changed in 150 years. So that's machine-centric versus human-centric. You can also see that we all like to work in different areas in different ways. What we don't have is the ability to not have the C6-7 compression from looking at our fingers all the time. I'm personally concerned about this because I think this is going to get worse as we spend more and more times on phones and tablets. We'll have more and more pressure in here. So probably the carpal tunnel of the 80s that kind of bit everybody happens again. I don't know if it's in 5 years or whatever. So how do we get to here? And by the way, you make an awesome volunteer. Keep playing. It's totally cool. It's awesome. So iterative product development for hardware. The first thing is understanding the problem. You guys understand this better than most people. The problem's multifaceted, and you're always trying to optimize these competing different things, right? So of course you got your customer wants, then the industry you work in, engineering, physics, manufacturing, and your investors, right? All have to be balanced out. So how do we get from this to this in 5 years is the story we're going to tell you. And then it took another year to get to that, right? So this is 6 years of development. The first steps, the first 2 prototypes, I would suggest to you were only valuable for understanding the problem. All right? They weren't even valuable as a solution to the problem. They were just enough to study the problem to the next level. So we tore the first one apart. I wish we had never done that personally. We kind of stripped it for parts. We probably got, $1,000 or $2,000 worth of parts from it, and we shouldn't have. We should have kept it. So it was horrible, and it barely worked, but it did some neat stuff, and it allowed us to study the problem. First thing that we did is we did a survey of working with computers in a reclined environment. There's lots of accepted studies for sitting and standing. We don't have to worry about that, but the reclined one was hard. So what we did is we took a bunch of different people, different heights, weights, genders, workflows, and we went through and did a study. And what we found was, one, everybody was really, really adamant about their comfort. Like 1 or 2 degrees mattered a lot. However, when we plotted the data, what we were hoping for, like good engineering, is, hey, we'll have like 3, maybe 4 data clusters, and we'll just make a machine that goes to those 4 points, and we'll get 90% of the market, and we can make it relatively easily. Unfortunately for us, what happened is when we plotted the data, it was a straight line, no data clustering whatsoever. So people were super adamant, and there's no clusters. So what we did, and you can kind of see with him playing around with this, think about this like an exoskeleton around the body. So that straight line of data with no clusters is where the beginning of the concept of human-centric computing came in for us. So that's what we ended up having to do. The next thing we did is, I don't know what your guys' prototyping rule is, but this is ours. If we have a bunch of smart people we work with, and if 2 smart people can come up with a path and they're reasonably well argumented, it's probably time to build hardware. So that's why we had to build all these things to get where we wanted to be in the end. So prototype 2 comes to be, which looks like it's going to chop off your fingers, and it's horribly ugly, and there's all kinds of problems with it, but it actually starts to kind of solve the problem. And we can start testing ideas. Every one of these things, we cut every piece of metal on that and did another try, right? So we do it and we're like, oh, let's cut that, weld something on it. So they get pretty beat up when you do that. So as you can see, instrumented out, all that, but maybe not totally unlike what we're talking about here. And so back to the drawing board. So in our case, there's just lots of sitting on the floor and staring at hardware. This is our CTO, John, the one that was rear-ended. This is our good friend, Doug. We built many projects together. So with prototype 2, we kind of have a crude answer to all the problems, right? And it just shows that we could solve the problems, that we understood the question. So prototype 3 is where we had a solution to every problem. So this is prototype 3. It weighed 350 pounds, could not go through normal doors, was horribly ugly, but it kind of worked. And there's the beginning of many solutions that we went through. It solved the problems, it wasn't elegant at all. Prototype 4, we said, how do we do all of that and put it in a silhouette that's a little more elegant? So more drawing boards, more paper. Real simple little prototypes like this were fantastic for us. This doesn't do anything other than have the basic shape, and it took about 20 minutes to put it all together and lock it in, and you can kind of say, is this what you guys are thinking? And we had something to talk about, right? So, Marcella, would you extend the leg rest? Being able to support the legs like we ended up doing, that was about 3 years worth of work and a patent around it. So I wish that little stool wasn't there, but the legs there are floating out completely. And what you can see here, just move this leg over for me. What we're really doing is we spring these out and we pull them back. And what that does is it creates an inherent safety switch, basically. So no one can sit on the end and flip the thing over. It also gives the user a little bit of compliance, a little bit of give when they're moving around, which adds to the comfort of the overall system. So those are the kinds of things that we had to solve. More sitting on the floor looking at stuff. More sitting on the floor looking at stuff. So this is the 4th generation prototype when it starts kind of getting together. A horrible idea for how to do the headrest that we hated. Best idea we had at the time, though. We tried armrests. Turns out, you'd think armrests would be a great idea, right? Chairs have arms. Well, a good portion of the population is slightly claustrophobic, and armrests make them freak out when they go and recline. Another thing you wouldn't know unless you tried it with enough people. Another thing we did in mechanical hardware was we started building multiple prototypes at the same time, because what we were finding is we would try something, it maybe wouldn't work as well as we thought it did, so when we didn't have anything to compare it to. So we went parallel path, and that really helped speed the overall process. So we could always refer to the last generation of prototype as we were going through and leapfrogging them. And then more sitting on the floor. This is a happy engineer. See, 5 pounds at that spot results in happy engineer. That's as happy as you'll ever see your CTO. These kind of problems. So the mechanism looks like it might catch hair. How are you going to test for that? We worked on that for a while, and we finally decided we're going to build it, and we're going to try some curly long hair and see how that goes. It works fine. Now you can start to see we've got the stand-up mode with the single arm that you guys see that we use. Finally got that to work. Magnetic desk that I showed you, turns out wasn't our first, second, or third idea, but it was our last idea. That's the one that worked. It starts looking like a chair. Focus mode starts looking like it's got the floating in space. That's industrial design wanted this idea of a single-sided swing arm and the human being floating in space at the center of the computing experience. That's what they thought the real drive was. And from an engineering point of view, it was probably cheaper to execute that than to put the second side on. So we went from that. Now we have these. And now we're starting to work the frame. So basically, the 4th generation of prototypes work the same as this. We actually have the 4th generation second prototype still in use today. It works great, but it doesn't look very good. So then we started working the rest of it. We started getting the monitor arm. You asked, how do we raise and lower? So the ability to do this, that kind of stuff was, that's a whole design project. And then long-term durability testing. So we've got over 1 million cycles on these things of various things. Like we dropped a 225-pound weight on it 100,000 times. Basically, one cycle we figure is once per hour. So 1,000 cycles is more or less a good idea for a year's worth of use in a normal work environment. So we just keep testing and keep testing. So now we're starting to get something that kind of looks like what you see, except for the part where it's kind of extra ugly and looks a little too industrial. So we changed the shape by changing the color. Who thought you could do that, right? So it wasn't just actual shapes, but contrast mattered, right? So we changed that, which is something you can see we still use today. So there's your CAD, and that's what it looked like. So that always means a lot. And then we start refining the details. There's a bunch of stuff in here that I would have to point out to you. Maybe you can see a couple of them that are different, but it's all the details. We get to this, then it starts looking like this, and then it looks like that. So, Battlestar Galactica second generation fans in the room? Thank you very much. Final 5. So we put jokes in with every one of these things. Just it keeps you going when you're doing this stuff and it's late. So we built 5 of them. There was 3 of them that we could show to press and customers, but the final 5 were the demo units. So our friend Aram, many of you probably know him. He has been a good friend of mine for a couple of decades, and we put him in the video. Another friend of mine, Kit. This leg rest that goes in and out was one of the favorite things that people just love about it. And I think it's absolutely beautiful. I know how much engineering it took to make that happen, which makes it even more beautiful. And then this is what we kind of end with. This is at South by Southwest, not this year, but the year before. And people, it's a different experience. When was the last time your desk delighted you? So with that, how about some questions?
How fast would you be able to turn an idea into something testable? Like, are you talking about days, weeks, months?
Yes, all of them.
All of them.
And I think that's a really important question when we look at. So it gets really, from a mechanical engineering point of view, to me, I think the biggest trick is, can you figure out a cheap and dirty test that gets you kind of the right answer? And I'll tell you an example of that. I'm going to go back. So it's back to this leg rest, right? So you can't see this, but this is a piece of absolute backyard, junkyard engineering to get that leg rest to work. And what we did there is I made something that would just kind of work good enough, right? And the leg rest was one of those problems that was very, it's what I like to call kind of a seductive problem. You think you got it, and you think you got it, and it really is actually 3 years of engineering to get there. So I put that in with some jack stands and some stuff, and really some junkyard engineering. John, our CTO, thought I was crazy. He's like, this cannot be that hard. I'm going to just go solve this, right? And so he made up this really interesting multi-cam system that had a big lever on it. And he got it all built, and it was all machined, and he puts together, and he's really excited, and he pulls it, and nothing happens. Because the velocity profiles on the cams, the accelerations, meant that it was almost impossible to get the thing started. It would work in theory, but you couldn't actually operate it with your hand. So he spent weeks coming up with that solution and getting it all machined, and we spent a lot of money on that. However, if we would have been able to just do one of those cams and try it in the shop and kind of grind it out and make it happen inside of a couple of hours, we probably would have figured out it was a dead end. So anything that we could do to do shorter little tests was way better. That's why the other prototype I showed you, which was literally just a cheap office chair from Office Depot, a knockoff of a famous one, with a piece of metal bolted to it and some other stuff welded on it. What we were trying to do is, if you're getting in and out was a big question, right? So what that cheap and cheerful little prototype did that was built in tens of minutes by our guy Doug allowed us to say, yeah, I can get in and out of this chair very easily if you do this for us, right? Other questions?
I'm just curious when in this process you started talking to manufacturers or considering manufacturing as part of the process, or is that
Yeah, we're in the middle of scaling manufacturing right now, so I'm kind of reflective on this. So I have a background in aerospace manufacturing. We built a lot of stuff that was really hard to build, and then we hung it on the outside of an airplane to see if it still worked, right? That was useful. What it didn't show us was, in retrospect, what I would have liked to have done is started to tour the facilities of other places and really deeply understand cost targets and how this stuff was done. So if I could go back in time, I would have just gone on all the little public tours and picked up the phone and worked on it. Not so much to talk to the manufacturers about how to do it, but just to understand the language. And so I would have talked to them much earlier.
Related question. You said this has been a 6-year process for you. With what seems like a very startup team. Is that a fair assessment?
Absolutely.
So when you look at a large-scale furniture manufacturer, what you're saying with the same iterative techniques which you do, how do you have a sense of how much you can shorten that? 6 months or 6 years? Like how much is a resource problem versus the experimentation iteration?
Another good question. So John and I would speak about that at length because there are some problems that just seem to take calendar time to come up with a solution, and you cannot throw people at them to try to solve it. I believe what we did that I think was really smart is we worked on our own with no investors' money for 4 years. Because we would have really fallen down if we would have said, oh yeah, we're going to have this done and we're still in the design process. Nobody thought that the leg rest would take 3 years to do, right? And if we would have had a bunch of people on that, could we have solved it earlier? Maybe, probably, but certainly not in a year, right? Afterwards, I think that it would have been good to be able to really leverage in. Right now, the way I describe it to manufacturers and to other people, the problems we have to solve now take a lot of work, but it's very predictable work. It's easy to knock down. You're like, I need to do this. It doesn't do this, or it costs this, or whatever. And how do I solve that? The inventive portion is the one that's really unpredictable. Good question.
Products, is MVP still something you think of, or do you have to like really get to your final state before you get it? Like, do you have this?
Yeah, believe it or not, I actually think that's our MVP. Right? I have literally heard people, if they want to be critical, they'll say that's like an MVP that went bad. But when you're doing something that's really different, in this industry here. If you go back, so this one right here, I would suggest to you in the 1960s or even early 70s, that's an MVP, that's marketable, right? You could have things that looked like they were cut out of the steel store and just put together, and that'd be okay. In today's modern world, if we didn't have the right fit and finish on this and the right, I don't want to use the word styling because it's not styling, it's really an industrial design solution that complemented the engineering itself. If we would have launched that product, I don't know that we would have had anywhere close to the response that we did have. In fact, I would argue vehemently that it would have fallen flat. So it really makes it tough. There's a bunch of stuff this thing doesn't do that I could imagine doing more, but we debated MVPs a lot. What we absolutely cannot do that you can actually get away with in software is the dead button or the blank button just to see if somebody clicks on it, if they even want that feature. That you can't do at all. Anything else? We'll be up here doing some demos afterwards if you want to come check it out. And thank you very much.